see the historical wing of pre-calculus. And if you look right here, you can see the pride and joy of our Museum of Calculus, the derivative. Great Scott! Someone has taken the derivative! Don't worry, sir. All this is gonna take is a little bit of calculus. I hope you're right, detective. A note? What kind of criminal leaves a note at the scene of the crime? Detective, I knew you'd be the one to find this note. It seems your precious derivative has gone missing. To find it, you must follow this riddle. In many places you must seek. Never let your calculus muscles grow weak. Take a journey to the originator of all. Evolve then to the man who is both short and tall. Go to those who make you see double. Remember the rule that keeps you out of trouble. After, find what the second can see. Let's start with the one who approaches infinity. One who approaches infinity. Blimey, that must be Ms. Limit. Ms. Limit, I have a few questions I want to ask you. Oh heavens, how good to see you, detective. Let's skip the pleasantries. Tell me what you know about the derivative. Oh dear, has something happened to the derivative? I remember when it was just a simple function, you know. I helped create the derivative. Ah, yes. Now, the days of this formula are long gone, but there was a time when all derivatives were created by beginner calculus students using this formula. But this is a modern age. If I were you, I would talk to Mr. Power. Thank you for your help, Ms. Limit, and for the formula. Detective, I didn't expect a visit from you today. Well, sir, I've got an important case to crack, and I was hoping you could provide me with some information. I hear you know something of derivatives? Derivatives, you say? I believe I've got just what you need. Look at this example here. We take the 6 in the exponent and bring it down to the front of the term. Now, we subtract 1 from the exponent and place it back in the exponent. Simple, really. That easy, huh? Well, it can get far more complicated than that. If you want help with more complex derivatives, you're gonna want to see the twins. The twins? Yes, the twins. Miss Product and Miss Quotient. They can tell you all you need to know about derivatives with multiple terms. Thank you for your time, Mr. Power. Mind if I ask you two a couple of questions? Oh, now this wouldn't be about the missing derivative, would it? Because as you can see, we've been busy all morning. Actually, this is a matter of utmost importance. I'm not here to accuse you, just to simply ask for your advice. If one of you were to take a derivative, how would you go about that? Now that's a question that we can answer. Let's take a look at this problem, for example. We need to take the derivative of this. So, we take the derivative of the first term, multiply it by the original second term, then add to that the original first term multiplied by the derivative of the second term. Then, of course, distribute that out and you've got yourself a derivative. Yes, that's all well and good. But what about when you have a denominator? Well, that's nothing my quotient rule can't solve. This is when we sing our little tune. Low D high, mine high, D low. Which means we'll take the low term, x to the third plus x, and the derivative of the term on top, subtract the original top term, and the derivative of the term on the bottom. And of course, don't forget, all of that will go over your bottom term
Yes, hello.
So good to see you, Sir Chain.
Very well then. Let's say we have a derivative to take. First, we use our power rules we have before. Bring the 2 down to the front. Keep the contents of the parentheses and subtract 1 from the exponent. But we're not finished. Multiply then by the derivative of the inside of the parentheses. And there we have a successful chain rule.
Wow. I never knew derivatives could be so complicated. Thank you, all of you.
Go now, detective. You've got a thief to catch.
It seems I've completed everything on this riddle. Except find what the second can see. What the second can see. The second derivative finds concavity. Blimey, that must be the concave.
The jig is up. Hand over the derivative.
I see you figured out the clues I left for you, detective. But it'll take more than that to get the derivative back. What have you done to the derivative? Isn't it obvious, detective? I took the derivative of the derivative. No, it can't be. Think. INTEGRAL. Integral. I have to take the integral. I've done it. Aha! It's over, calculus teacher. I have solved your riddle and found the derivative. Your plan failed. But that's where you're wrong, detective. By completing my riddle and finding the derivative, you yourself have become a calculus master. This was my plan all along. Save it for the judge. Oh, detective, thank you for all of your hard work. Without you, we may have lost the derivative forever. All in a day's work, sir. I'm just happy to see that criminal behind absolute value bars.